Question 14d. At a certain factory, the proportion of faulty items produced by a machine is P equals 3 over 500, which is considered to be acceptable. To confirm that the machine is working to this standard, a sample of size n is taken and the sample proportion P hat is calculated. It is assumed that P hat is approximately normally distributed with mu equals P and sigma squared equals P multiplied by 1 minus P over n. Production by this machine will be shut down if P hat is greater than or equal to 4 over 500. The sample size is to be chosen so that the chance of shutting down the machine unnecessarily is less than 2.5%. Find the approximate sample size required, giving your answer to the nearest thousand. By the empirical rule, the upper 2.5% of the normal distribution with mean 0 and standard deviation 1 is from z-score greater than or equal to 2. P hat is approximately normally distributed with mu equals P, which equals 3 over 500, which as a decimal is 0.006, and the variance sigma squared is equal to P multiplied by 1 minus P over n, which equals 0.006 multiplied by 1 minus 0.006 over n, which equals 0.005964 over n, and we'll call that equation number 1. Using the z-score formula, we want P equals 4 over 500 to correspond to a z-score of 2. So from 1, a z-score of 2 is equal to 0.008 minus 0.006 over sigma, which is the square root of sigma squared. So we get 2 equals 0.002 over the square root of 0.005964 over n, which is just the square root of the right-hand side of equation number 1. Next, we solve for n. So the square root of 0.005964 over n is equal to 0.001. 0.005964 over n is equal to 0.000001. So that's squaring both sides. And making n the subject of the formula, we get 0.005964 divided by 0.000001, which equals 5,964, which is approximately 6,000. So approximately 6,000 samples will need to be taken.